Hi guys, today we are learning a cryptocurrency price prediction using LSTM. So we need to download the data, so that's why Yahoo Finance library has to be installed by using pip, and then we are importing the libraries Wave Finance as YF, importing NumPy, importing Pandas, importing min-max scaler to scale the data, and our model is sequential. So you can add the layers in sequence, and the layers are LSTM and dense. We generate the time series data, so that's why importing the class time series generator. Then we check the decomposition, and then we need to evaluate our model. The metrics are mean square error and mean absolute error. We are importing matplotlib because we need to plot the graphs. So at first we import the required libraries, and then we have to download the data. So that's why vf dot download. So we are downloading this Ethereum USD and US dollars starting from this date 2021 month 1 day 1 to 2023 month 11 day 30. So once the data is downloaded, we just reshape the values of this close price. You can mention any other column like opening price, transactions, like anything. So I'm focusing on close price, and then reshaping the values to -1 and -1. That is the one dimensional data is converted. Then we need to scale the data. So scalar is equals to min max scalar of feature range in the range of 0 to 1. That means data values are put into the range of 0 to 1, and then fitting and transforming the data. So this will download the data and then reshape, then scaling is done, and then fit it to the scalar. And then we split the data into 80% and 20%, 80% training and 20% testing. So train size is equals to integer of length of scale data, so multiplied by 0.8, 80%. Then we split this, we divide this data into training and testing. So train data, test data is equals to from the scale data. This is slicing starting from 0 to train size, and then from train size to end is not mentioned, so means by default up to the last. And then we are defining a method here, create sequence. We need to create a time series sequence, so that's why the method is written create sequence, which is taking two parameters, data and sequence length. And this is Python empty list for I in range of length of data to length sequence length -1. The data is appended to x and y, and this will return us the array. It will return us the arrays. We store the features into x, and y means target variable. Then we are specifying the sequence length here, sequence length 10, which is no customizable. You can change this value. Then calling the above method here, create sequence, passing the parameter train data sequence length. Then the data is split into x train, y train, then also getting the test data, x test, y test, and then again reshaping these values into in the range of -1 and 1. And then so here we are building a model. So once the data pre-processing is done, you can build a model. So the layers in the models are, the first layer is LSTM with 50 neurons, return sequence is true, and input shape is equals to sequence length comma 1, so it's a one column. Then again adding the LSTM layer with 50 neurons, and then a dense layer which can give the single value. So a single value prediction, that means close price. So this is the definition of the model. So once the model is defined, you need to compile. So while compiling, you need to specify what is your optimizer. So optimizer is Adam, and then mean square error is the metric to evaluate, and then fitting the data to the model. So model always learn from train data. So fit of x train comma y train. The number of epochs we are mentioning 100. The batch size 32, means at a time 32 rows are fitted to the model. So now the data is fitted to the model, means it is learning. So so as you know, if the number of epochs are more, model always gives the better performance. This is not true in all the cases, but more epochs, more learning. You see, initially the loss was 0.04%. Now it is decreased, because it is decreased to this one decreased to 9.99 e to the power minus 0.4, means it's closer to 0. So once the model is defined and also compiled, then we can make the prediction for X test. So making the prediction for X train, or also making the prediction for X test. Then we need to perform inverse transformation to get the original data values. So once it is done, we are now plotting a graph. So we are plotting a graph. So plt dot plot of scalar dot inverse transform of the actual data. The label is true value. Then we are also plotting the model predicted values. So np dot concatenate joining train predicted and test predicted. Label equals to predicted. Then x-axis label is time and y-axis label is ETH price. Then legend is also added, and we can also see the um, graph. You see, true values are these, and predicted values are just a straight line. This is not correct, but this is just no straight line. Then so we are getting the close value, that means actual value, and then checking the seasonal decomposition between the actual value. ETH close, the model is multiplicative for a period of 30 days. You can just change this also, and then having a figure, specifying the figure size 10,8, and then figure size here. So no need to specify two times. I think we are doing it two times. And then having a subplot, 4 rows 1 column at a time. For the first time, first figure is active on which original values is stored. Then in the second plot, trend values is shown, and the third plot, seasonal decomposition values are shown, and we're also showing the residuals. So once you run this cell, you can see the output right here. You can see the original value. So by just looking at with our naked eyes, we can see there is a trend, and also there is a seasonality. Data has increased and also decreased. So there is a, we cannot say there is a positive or negative trend, but increase decrease trend is there. And also if you check the seasonality, there is seasonality, ups and downs are there. And then residual means errors are also there. So residual means which shows the errors. So nothing but after removing the trend and seasonality components, you'll be getting the residuals. So if you plot a line, so the values must fall on the line. Next, we are specifying the sequence length here, and then we are generating some time series data. So train generator equals to time series generator of scale data, passing the scale data. Length is equals to sequence length, that means 10, and the batch size is 1. And then again test generators, and now again building a model, the things are same here. So now after using the time series generator, so you can see the model building for apex 10. We mentioned the number of racks as 10, and we can see the loss. So loss is decreased and the performance of the model is increased. So you can see in APAC 1 of no 1 of 10, loss is 0.0055, and then it is decreased. It has to be decreased. You can see the loss has been decreased from 0.005 to 0.0011. So the loss is decreased. Now we can fit the data. We can fit the train generated data for apex 10, and then we can observe the loss. We can observe the loss with respect to the number of apex. So we can have a plot here. The title of the plot is loss per apex, and the x-axis label is apex, and y-axis label is loss. So we are plotting the loss on the graph. As you can see, the loss has been decreased from 0.002 to 8.621 e to the power minus 0.04. That means very closer to 0. We can now observe this on the graph. On x-axis we are showing the number of packs, and y-axis showing the loss value. So loss is decreased, and then we'll get the last sequences from the train data and then making the predictions. So last sequence equals from scale data minus sequence length, so getting the last sequences. Then for I in range of 10, we are making the prediction for next 10 days, so that's why we have mentioned 10. Otherwise you can increase or decrease the value. Then making the prediction, model dot making the prediction for last sequence, reshaping the data. Then predictions are appended to the predictions of Python list, and then getting the last sequence updated. Then we need to apply the inverse transform function on the data set to get the original data. Then also generating the dates for next 10 days. Last date equals to ETH data dot index of -1, and then specifying the data range. Then having a plot. So on this plot we are showing the close value. That means historical data is nothing but past data. You see the blue color one is showing the historical data, past data, and what the model has predicted. So what the model has predicted is now represented by using this orange color. So that is the prediction for next 10 days. Means we have the data up to November. That means it is going to make the prediction for December 10. So this is the predictions forecasting. And then taking the first 10 days, so for the dates, so having a figure of on x-axis we are showing the dates, and also on y-axis you are showing the price. Got it? On y-axis you are showing the price, so you can increase the width here to 15 so that we can have a proper dates displayed. So these are the values. You see December 12, month to December, date 9. So this is the actual versus and what the model has predicted. So and we can also evaluate our model by using the mean square error and mean absolute error. The value is quite lower here. The error is very low, 0.0002. So that's it from this video. So today you have learned how to build a LSTM model for cryptocurrency data. So LSTM is the a recurrent neural network, for example. So if you have any data, then you can follow up the same process to build a time series model.